Hello and welcome to lesson 3.2 called Graphing Quadratic Root Forms by Emma Feldman. So the equation for the root form is y equals, or f of x equals a times x minus root 1 times x minus root 2. A root is wherever the parabola of your quadratic equation crosses the x-axis, and you can have 0, 1, or 2 roots. And another name for root is the x-intercept, 0, solution, but the most common name is a root. To find the root, you have to take whatever's in the parentheses of your equation and set it equal to 0, and you solve those equations individually. And whatever you get as your answer not only determines the number of roots you'll have, but the value of those roots as well. And whether your equation has a minimum or a maximum is all depending on the a. If your a is positive, then the parabola of your quadratic equation will have a minimum, which means it'll open up, creating a smiley face shape. But if your a is negative, then your parabola will have a maximum, which means it'll open down, creating a frowny face shape. To find the y-intercept, you have to plug 0 in for the x's, because whenever the parabola crosses the y-axis, x equals 0. So you plug 0 in for all the x's, and you solve the equation. And whatever you get as your answer is the y-coordinate of your y-intercept. So the axis of symmetry is basically a line going through the vertex of the parabola, creating, when it's drawn, it creates two congruent halves of the parabola. And the value of the axis of symmetry is also the x-coordinate of the vertex. And to find the vertex, you do what I just said. You take the value of the axis of symmetry, and you plug that in for the x's in the equation. And you solve the whole equation, and whatever you get as your answer is the y-coordinate of the vertex. So your vertex is made up of the axis of symmetry as your x-coordinate, and the value we just found out as your y-coordinate. So here's an example of an equation with root forms. So we can already determine whether our equation has a minimum or a maximum just looking at it, because well, the a equals 1, well, it's not here, but we know a equals 1, and because 1 is positive, the parabola of this equation will have a minimum, which means it will open up, creating a smiley face shape. So here are the roots. You take x plus 2 and set it equal to 0, and you take x plus 2 and set that equal to 0. You solve both of them individually, and you end up getting the same thing, which indicates that there is only one root for this equation, and it equals -2. The y-intercept is shown here, so you plug 0 in for the x's, and you get 0 plus 2 times 0 plus 2, and then you get 2 times 2, which equals 4. The vertex for this equation is -2 plus 2 and times -2 plus 2, which ends up being 0 times 0, which is 0. So the vertex is -2, which is the axis of symmetry, and 0, which is the number we just came up with. So here's a graph of what your equation would look like. You can see the -2, 0 coordinate, which doubles as the root and the vertex here in this case. The y-intercept is shown here at 0, 4. The axis of symmetry is drawn through the middle. And the value of the a also determines the steepness of your parabola. So 1 is like the normal kind of steepness. And you have your domain and range here. The domain is -infinity to infinity, and the range is -2 to infinity. So here's our second example, and so we see our a is -2, and because a is negative, this means our parabola of this equation will have a maximum, which means it'll open down, creating a frowny face shape. So our two roots are here, so you take x minus 2 from the first parentheses, set that equal to 0, and you take x minus 6, set that equal to 0, and you end up getting x equals 2 and x equals 6. So those are your two roots, 2 and 6. The y-intercept is shown here. You put 0 for both of the x's, so you get negative 2 times negative 2 times negative 6, and then you get negative 2 times 12, which is negative 24. And the vertex here is first you take the axis of symmetry value, which is 4, and the axis of symmetry is 4 because your two roots are 2 and 6, and 4 is in the middle of that. So you plug in 4, you get negative 2 times 4 minus 2 times 4 minus 6, then negative 2 times negative 2, then negative 2 times negative 4, and you get 8. So your vertex would be 4 and 8. And this is what it would look like. So your maximum would be upside down, and since the A is 2, it's slightly steeper than if A were 1. Then you have the axis of symmetry, you can see the two roots, and unfortunately the y-intercept was too low to display on the graph, but we understand that the y-intercept is negative 24, and the domain is negative infinity to positive infinity, and the range is negative infinity to 8. And so the last example is y equals, or f of x equals 3 times x minus 3 times x plus 1. And the two roots are shown here, so you take x minus 3, set it equal to 0, and x plus 1, set that equal to 0, and so your two roots for this equation are 3 and negative 1. The y-intercept, when you plug 0 in for the x's, you get 3 times 0 minus 3 times 0 plus 1, 3 times negative 3 times 1, 3 times negative 3, and you end up getting negative 9 for the y-intercept. The vertex, the axis of symmetry is 1 because it is in between negative 1 and 3. So you have 3 times 1 minus 3 times 1 plus 1, 3 times negative 2 times 2, 3 times negative 4, and you get negative 12 for the y-coordinate of the vertex. And here is a graph showing this, and again, unfortunately, the vertex y-coordinate was too low to actually see the vertex on the graph, but we know where it is. You see the two roots, the axis of symmetry, the A equals 3 this time, so the parabola is even steeper, and if your A was anything less than 1, then your parabola would become wider, and but that's not in this case, and the domain is negative infinity to infinity, and the range is negative 12 to infinity. And that concludes this lesson, so thanks for watching Graphing Quadratic Root Forms.